So lesson 8.6 is solving rational equations. These rational expressions we've been factoring, simplifying, multiplying, dividing, adding, subtracting. Well, now it's time to solve equations with them. A rational equation contains at least one rational expression and one equal sign. It's not an equation if it doesn't contain an equal sign. It's not a rational equation if it doesn't contain some kind of rational expression. So, yes, they have fractions in them. Okay? Easiest method to solving really anything with a fraction. You guys don't like dealing with fractions, do you? So, yeah, I'm kind of right there with you. So the easiest thing to do is we're going to start by getting rid of the fractions.
Yes.
Okay, so we don't have to work with them. So that's going to be the main thing, is that we're going to want to clear the fractions out. In order to clear the fractions out, we're going to multiply both sides of the equation by the common denominator. So just like adding and subtracting, we are going to have to find a common denominator. It's not that we're getting a common denominator. We're going to have to know that because that's what we're going to multiply by. And then a side note, so we don't forget it for later, we are going to have to check our answers. And the big thing we have to make sure is that it can't make the denominator equal to 0. Because if it makes the denominator equal to 0, it's not an option. So our last step in all of these, because there are denominators, fractions, denominators, letters in those denominators, we have to check our answers. The check will be a pretty easy check, though. It'll just be making sure it's not one of our restricted values. So, as we look at example A, we did common denominators the last couple of days, right? What do we have to do before we figure out the common denominator? We have to factor it, right? So, just like what we've been doing the last couple of days, do any of my denominators need to factor there?
Yes.
X squared minus 9, is that one we know how to factor? It should be, yes. X squared minus 9 factors into 2 parentheses, x and x. The square root of 9 is 3. And when it multiplies to be minus 9, it's going to be a plus 3 minus 3. So that is what that denominator factors into. The other two denominators, x minus 3 and x plus 3, do they factor? No, they're already factored. And is it coincidence that there's overlap here? Definitely not. Okay, I would expect to see overlap. So, my question to you, I'm not sure I really left myself enough room there. I didn't. My question to you is going to be, what would be the least common denominator for this problem? And think like we've been doing it the last couple of days. First thing I'm going to ask you is, what's in common, and then leftovers. Are there any pieces in common?
3.
Okay. There's x plus 3 here, x plus 3 here, yes. So there's an x plus 3 in common. That's part of my common denominator. There's also x minus 3, x minus 3 in common. So that's part of my common denominator. Are there any other leftover pieces? Does x plus 3 and x minus 3 include everything? And it does. So my least common denominator is x plus 3 times x minus 3. And what we're going to do with that least common denominator, notice what it said? We're going to multiply both sides by the common denominator. So I'm going to multiply this entire equation by x plus 3, x minus 3. Okay? We're going to multiply the entire equation. So every piece will be multiplied by x plus 3, x minus 3. Now, for teaching this, I'm going to write it out the long way. Okay? Some of you, as you start to follow and understand what I'm doing, you might choose to not write out what I'm getting ready to write out, but I'm going to write it out the long way. because I want to show that we're taking each term and multiplying by x plus 3, x minus 3. So we're going to take this first term, x over x minus 3. We're going to multiply by these two. We're going to take the second term, x plus over x plus 3, multiply by these two. And on the other side, the 2 over x plus 3, x minus 3, we're going to multiply by x plus 3, x minus 3. So first thing I'm going to do is I'm going to kind of spread my equation out so I can show this. And trying to think how I make this fit usually. So I'm going to have x over x minus 3 plus, I'm going to leave a gap so I can put what I'm multiplying. Then I'm x over x plus 3 equals, and I'm going to leave a gap so I can put what I'm multiplying by. And then it's the 2, and it was over x squared minus 9, but I'm going to put it as x plus 3, x minus 3. I do have B as one of my examples planned. So, I know, but I'm not going any farther than that. And this is the long line right here, okay? Now, what am I multiplying each piece by? X plus 3, x minus 3. So I'm multiplying the first fraction by that. I'm multiplying the second fraction by x plus 3, x minus 3, and I'm multiplying the other side of my equal sign by x plus 3, x minus 3. Now, as I multiply, I'm multiplying this x plus 3, x minus 3 by a fraction. How do we make x plus 3, x minus 3 a fraction? How do we always make stuff a fraction, right? So you notice I kind of set it up that way. But each of these, you can think about them being over 1. Now, the whole point of multiplying by x plus 3, x minus 3 is there should be a ton of canceling happening. As we look at this first set, x over x minus 3 times x plus 3, x minus 3. What cancels? Okay, a factor of x minus 3 cancels with a factor of x minus 3. What remains? X plus 3 and x. Notice, is there anything that remains in the denominator other than 1s? No, and that's the whole point. We're getting rid of denominators. So I'm going to write down here my next line that remaining here, I have an x and I have an x plus 3. So that's my first piece.
Can I go ahead and distribute or
I'm going to do that next step. If you want to go ahead and distribute, you can. Now, I carried down my plus sign, right? What cancels in my second set? Yeah. X plus 3 on bottom cancels with x plus 3 on top. What remains? An x and an x minus 3. I'm going to carry down my equal sign. On the right, what cancels? X plus 3 cancels with x plus 3, and x minus 3 cancels with x minus 3, leaving me with 2. There's still work to do, but we at least got rid of the denominators. Does that make it at least look somewhat better? Mm-hmm. Okay. Now, are you going to always write out that big long step I just wrote out? I don't know. You can get to the point where you can cancel that in your head. That's fine. Okay, I wouldn't necessarily always write that out, but I feel like I need to demonstrate right now what we're learning. Okay, what is my next step? We've got to solve this, so Lorna asked earlier. Do we go ahead and distribute? I'm going to distribute now. I didn't want to do it quite yet, but I'm going to distribute now, so we got to solve the equation. X squared plus 3x, and then x times x, and x times minus 3 is going to be x squared minus 3x, and it still equals 2. Okay, mathematically. We're at the easier stuff. What's next? Okay, combine like terms. X squared goes with x squared. What's x squared plus x squared? No. 2x squared. 1x squared plus 1x squared is 2x squared. What else happens here? 3x's cancel, right? 3x minus 3x is gone. So on this side, I have 2x squared equals 2. How do I solve? All right, since it's 2x squared equals a number, we're going to divide by 2. We divide by 2, we're going to have the statement left of x squared equals 1. What is that last step? Square root, right? When you have x squared equals a number, to get x squared to become x, we take the square root. If you take the square root of one side, take the square root of the other side. So the square root of x squared is x. What's the square root of 1? Square root of 1 is what? Not just square root of 1. Okay, 1 and plus or minus. Okay, so first of all, don't leave it as square root of 1. Typical mistake there. I don't know why you guys don't like the square root of 1, but I always get that. Square root of 1, 1 times 1 is 1, so square root of 1 is 1. And then when you take the square root in an equation setting, you always make it plus or minus. Now, I mentioned up above, what's always got to be my last step today? Check. Now, this doesn't need to be fancy. You don't have to go as, you can, but you don't have to go back to the original equation, plug 1 in, and plug -1 in and see if they work. Here's what I want to know. If I was doing restrictions on the variable, what would be my restrictions? If we go back and look at our denominators, what could x not equal? 3 and -3. Did I get 3 or -3 for answers? No, I got 1 and -1. Are 1 or -1 going to make any of these denominators equal to 0? No. So my 1 and -1, they check. Does that check make sense to you? It's not anything that you have to write down, but you need to mentally check because on occasion they won't work. Okay?
So if it doesn't work, would you,
if one of these worked and one of them didn't work, you'd just go from 2 answers to 1 answer. If neither of them worked, it'd be no solution. Is that what you're asking?
Yeah, it was just like if it was one of the restricted.
Right, yeah. Like if, 3 or -3 was one of our answers, then you just X that out, and even though it appeared to work, you'd say no solution. Because here's the deal. 1 and -1, this is the equation they work for. It doesn't take into account that there were originally denominators, and denominators can't be 0. Okay? Questions? Got an idea? It's similar to other stuff we've done. It's not, it kind of follows what we've been doing lately, doesn't it? I am going to have us do B. B is another example I like. So, with B, I'm not going to bother reading that equation. You guys can read it. What is step 1? Okay, just like last lesson, we're factoring, right? We're going to factor these. X squared plus 3x plus 2. Does it factor? It does. X squared is x and x. What multiplies to be 2 and adds to be 3? 1 and 2. And both positive? Coincidence? Not really. We expected it, right? I'm more concerned if they don't match. Now, and we saw one yesterday where one matched and one didn't. But if nothing matches, that's where I get concerned. Okay, so let's talk. What's going to be my least common denominator? What are the factors I have to make sure I use here? Okay, he says x plus 1 and x plus 2. What's in common? There's an x plus 2 in common here between the first two fractions. There's an x plus 1 in common between first fraction and last fraction. Any other leftovers that we've overlooked? No. So x plus 2, x plus 1. What's this mean I'm doing here? If my least common denominator would be x plus 2, x plus 1, I'm not getting a common denominator. What am I doing with that common denominator? Multiplying by it. Yep. And I'm going to write this one afterwards. We're going to multiply by x plus 2, x plus 1. I'm going to write out everything like I did last time. If you want to try your canceling step and see if you meet up with me correctly, you can try that if you don't, want to write it out. Or you can wait till later. But I'm going to kind of write out my equation here, and then in front of each term, I'm going to put what I'm multiplying by. So I'm going to leave a space in between here, or in front here. And I'm going to have x minus 1 over x plus 1, x plus 2. I'm going to say plus. I'm going to leave a space. And then I'm going to have 2x over x plus 2. I'm going to say equals. I'm going to leave a space. And I'm going to put x minus 1 over x plus 1. And again, I'm just spacing out the original problem so I can write what we're multiplying by. What am I multiplying each of these three terms by? X plus 2, x plus 1. So, x plus 2, x plus 1 is multiplying by the first fraction. I'm going to put it over 1. I'm going to put it in front of the second fraction. X plus 2, x plus 1. Put it over 1. And I'm going to put it in front of the third fraction. X plus 2, x plus 1 over 1. Just be careful if you don't write this step out that you really do know what you're doing, and say next week when we're reviewing for Chapter 8 test that you remember. Okay, so I guess you might want this step actually. Okay, canceling. First fraction, what cancels? X plus 2 with x plus 2, x plus 1 with x plus 1. What remains that I'm going to carry down to my next line of work? My numerator of x minus 1. Carry down my plus sign. Next time, what cancels? X plus 2 cancels with x plus 2. What remains? There's an x plus 1 and a 2x, right? I personally am going to put my 2x out front and say 2x times x plus 1. And I'm doing that just because 2x is a single term. So I prefer to have that kind of stuff out front. And last piece. What cancels? X plus 1 cancels with x plus 1, and I now have x plus 2 times x minus 1. Okay. If you skipped writing a step out up here, this is where you check and make sure that we have the same pieces written out. Okay? Okay, guys. Take our steps. What kind of steps do we need to do here? Okay, the 2x is going to have to distribute, which x minus 1 I can just carry down, right? And I'm going to carry down my plus sign, and then this 2x we have to multiply it, so we're going to distribute. 2x times x is 2x squared, right? 2x times 1x is 2x squared, plus 2x times 1 is 2x. What do I have to do on the right? FOIL, yes. Okay, know when to use that FOIL. So, x times x, x squared, x times minus 1, minus 1x. Then I'm going to distribute my 2. 2 times x, 2x. 2 times minus 1, or 2 times negative 1. Negative 2. I'm glad you said that. I hope you guys are watching. You weren't going to let me continue past that mistake. In my brain, briefly, 2 times 1 was 1.
I glanced up at the split second.
Yeah, 2 times 1 is 1 today in my world. I don't have an answer. Which is why it helps when you guys say stuff out loud, because I was like, why is he saying 2? Oh, wait, why am I writing 1? What? Not necessarily. Again, it'll depend on timing. Because the next example I know I'm jumping to is E. A, B, and E are the 3 that I know I want to try. I don't know if we'll get past E or not, because these take a little bit, don't they? At least when I'm leading you through. Okay, did some of you guys go on without me? No?
I tried, but I don't know. Yeah, I've been trying, but I keep getting like.
Okay. Well, I would say let's clean up like terms on either side and see kind of where we're at there. Which on the left, if I clean up and reorganize, I've got a 2x squared. And then I'm looking at the fact that x plus 2x is going to be 3x. And I still have a minus 1. My brain works in that quadratic order there. Okay. On the right, I just didn't clean up my FOIL when I wrote it, did I? So there's x squared minus 1x plus 2x is x, or 1x, and then minus 2. Now, thoughts on where to go next? Well, like put them together?
Yeah.
More than just that, though.
All the entire thing.
Okay. This is quadratic, right? We've got a squared term, an x term, and number terms. When we have each of those 3, we're usually going with the idea of make the equation equal to 0. So we're going to make it equal to 0. And yeah, I'm going to be running down to the bottom of my board. So if you guys run into D a little bit, it's okay. I like to keep a positive x squared. So I'm going to take everything on the right and move it to the left. So to move a positive x squared, I'm going to subtract x squared over. To move a plus 1x, I'm going to subtract 1x. And to move a minus 2, I'm going to add 2. I know I wrote that in small, but I'm just trying to show the steps there. Okay, where are we at? What do we have? 2x squared minus x squared is going to be 1x squared. 3x minus 1x is 2x. Negative 1 plus 2 is plus 1, equal to 0, because everything canceled out on the other side. The good news is this is doable. You know what to do? Do you remember? How do we solve? Because we are going to solve.
Oh, yeah, you put the 1 to the other side and all the way to 2.
I'm not going to subtract the 1 over.
But you break it into separate.
No, you would.
I heard
bring
factor.
in 2 equations and then set each equation equal to 0.
2 parentheses, 2 factors, right?
Oh,
Some of you guys were headed that way. Some of you guys weren't. I wasn't sure about. So, yeah, we're back to factoring. X squared plus 2x plus 1 is a nice factorable equation. X squared breaks into x and x. What multiplies to be 1 and adds to be 2? 1 times 1 is 1. 1 plus 1 is 2.
-1.
Yeah. Officially, your step is 2 factors multiplied equals 0, so we set each factor equal to 0, right? So I set, I'm going to go over here, x plus 1 equals 0, and officially, x plus 1 equals 0. Did I really need to set them both equal to 0 in this case?
No.
Not really. They're the same answer, right? If it's x plus 1, what do we do? Subtract 1. What's my answers? X equals -1, x equals -1. Do I need to write them both? No.
I need to check. I think that
Okay. And we always, last step today, check your solution. Is -1 okay? No? Why not? If I go take -1 and I put it, say, in this denominator right here, -1 plus 1 is 0. That's a problem. I can't have 0 in the denominator. Okay? My restrictions on the variable here would tell me that x cannot equal -1 and -2. So there's 2 numbers that we can't get. And what did we just do? We got one of them. So, -1 does not work. Did we have any other options to fall back on? No. So guess what? No solution. Yes, unfortunately, all of that for no solution.
wow.
I like this better when I'm on paper in a way because I can run down a little bit more here. Kind of ran out of room, but
Yeah, I was very close.
well, if you look at my notes here, you know, I ran down in the side in previous years, so.
I just kind of gave up and did it all.
So
There you go.
Did you have the previous years you did it underneath? That
Yeah, I was still using it. Yeah, this is new. Well, this
Right.
beginning of this year I started with Elmo,
Yeah.
if you recall. So, okay. The other one I said I wanted to look at was E. So let's look at E.
Oh, I remember videos on that. Take notes and stuff.
Yeah. The video quality is much better here. So, real quick, C. If we were doing C, what would I be multiplying both sides of my equation by? What?
Wait, it would be.
Yeah. If we were doing C, I'm not going to do C, but I just want to talk about it for a moment. We'd be multiplying both sides by what is my common denominator? X plus 2. So you can multiply by x plus 2. If we were doing D, what would I need to multiply both sides by? Yeah. X plus 1 and x plus 4 would be my common denominators, right? Okay. Now, we're really truly going to move on to E. And as always, what has to be our first step? We have to factor our denominators. C and D didn't need factored. E needs factored. However, I have it on the next screen as well. That gives me a lot more space. So, I like this better. Okay, factor. X squared minus 5x. How does x squared minus 5x factor? Okay, this is a GCF, isn't it? So if we factor out a GCF of x squared divided by x leaves me with x, minus 5x divided by x leaves me with minus 5. So that first piece factors into x minus 5. What about x squared minus 5x again? Factors the same way. X minus 5. What about that third fraction of x? It's just x in it, isn't it? No factoring there. So, tell me, least common denominator. What kind of things do we have in common? Okay. So 2 of them have an x minus 5 in common, yes. So x minus 5 is a piece. And x, x, x. All 3 of them have an x. They just have a single x though, right? So my least common denominator is going to be x and x minus 5. So x and x minus 5 is what I'm multiplying everybody by. Okay, I'm going to spread it out and write it out. Hello. I do not. She's not one of my students. Who did you mean to call? Mrs. Sargent. I don't know. She's not a student of mine at all, so that's fine. Okay. Okay. Okay, well, she's in math at least right now, but yeah, not in my math class. Okay, no problem. Bye. Okay, did you guys start spreading this out? Okay, I'm going to leave some space in front of the first fraction. First fraction is 1 over x, x minus 5. Equals, I'm going to leave some space. My next fraction is 4 over x, x minus 5. Minus, that minus will be important, guys. Part of the reason I picked this one. Spreading my fractions out here. X minus 7 over x. Each of those gaps, I'm going to write that I'm multiplying by x, x minus 5. X, x minus 5. X, x minus 5. And all of those x, x minus 5s I can put over 1. What cancels? What cancels on my first set? X cancels with x, and x minus 5 cancels with x minus 5. Important question to answer correctly. What remains? 1. Don't tell me nothing, because even when everything cancels out, there's always 1. So it's going to be a 1. Equals. What cancels next time? X, x, x minus 5, x minus 5. What remains this time? 4. Okay. This time I'm carrying down a minus sign. What cancels? X cancels with x. What remains? Okay, x minus 7, x minus 5. So I'm going to write this as x minus 5, x minus 7. Keep in mind, there's a subtraction sign in front of those parentheses, which will be important here in a moment. Okay. We got to do some math? Okay, math we got to do here. We need to FOIL. Now, as I FOIL this, because it's being subtracted, I'm actually going to put this into parentheses because we need to subtract it here in a moment, and I'll show you what that means. So x times x is x squared. X times minus 7x, or excuse me, x times minus 7 is minus 7x. X times minus 5 is minus 5x. Can I go ahead and put them together this time? Minus 7x and minus 5x is going to be minus 12x. And minus 5 times minus 7 is going to be plus 35. Okay. You guys know you kept getting messed up on 8 and 10 yesterday because of subtracting issues, right? This is exactly that same type of mistake if we're not careful. My next step, realize everything in this last piece is being subtracted. This subtraction sign, basically, I can distribute as a negative, and it just changes all of my signs. So I'm going to rewrite this as 1 equals 4 minus x squared minus a minus 12x is really going to make it plus 12x, and then minus a positive 35 is going to be minus 35. Does that make sense? Those signs are important. Now, what do you see? What?
Perfect. Square thing you change the x squared.
X squared? Okay. So we're probably going to be able to factor this. First of all, let's do a little bit of cleanup. If I do some cleanup here on the right, what is 4 and minus 35? Minus 31. So I still have 1 on the left. I have negative x squared plus 12x and then minus 31 on the right. We need to make this equation equal to what? 0. How can I make it equal to 0? Okay. Subtract the 1. If I subtract the 1 here, subtracting the 1 here, 0 equals negative x squared plus 12x minus 32. We need to factor. How do I feel about negative x squareds? I don't do it, do I? How can I make this so it's not a negative x squared? Okay. I think I heard both options. We can move everything to the other side, couldn't we? Or how about we multiply everything by negative 1? We can do that because it's an equation. You can also factor out negative 1. But I'm going to go with, let's multiply everybody by negative 1. If you multiply one side of the equation by negative 1, you multiply the other side of the equation by negative 1. But what is negative 1 times 0? It's 0. When I multiply negative 1 on the other side, all my signs change. So it's positive x squared minus 12x plus 32. We're almost there. You know these last steps. We're going to take x squared minus 12x plus 32 and factor it into 2 parentheses. X squared breaks into x and x. I need what multiplies to be 32 and adds to be negative 12. 4 and 8. If it multiplies to be positive, they're the same sign. Since it adds to be negative, both negatives. Officially, I'm going to set each part equal to 0. So x minus 4 equals 0. X minus 8 equals 0. We get solutions of add 4, you get 4. Add 8, you get 8. So we get solutions of 4 and 8. What is my last step? Check. Are 4 and 8 okay in my denominators?
Yes.
Yeah. The issues in my denominators would have been 0 or 5. Okay? So, these do check. Okay, guys. Your homework. And yes, it should be showing us due tomorrow. Is Math Excel. Lesson 8-6. And no, I do not necessarily plan to do any more notes. Okay? I'm more planning I'd rather help with homework. So get in the homework, give it a try, write them out, see what you can do with them, and we'll deal with questions tomorrow.
Are you gonna kill me?